Okay, let's check the sound if you can hear me well. Good. How many people did we have last lesson? $38. Okay, it's 24 right now. So we're gonna start in about a minute or so. Just let's let a little bit more people join. So today we will be talking about SQL, and that's pretty interesting topic, something that eventually you'll have to deal with, maybe not immediately, but SQL is everything to do with working with databases and getting data from the databases, updating it, looking at it. It's mostly and primarily used by backend engineers and analysts that work with databases or administrators. But as testers, we use it sometimes as well. And this is to verify the data on the backend in the database. If, for example, we don't have access to verify it on the front end. It's also quite common to have questions on the SQL during the interview process. And you can expect during the interview being asked some SQL questions, even though you might not use it at the job, which is kind of funny. But it's also when jobs, QA jobs require SQL, for example, it will mention. So it will mention in the job description that SQL is required, and then you'll definitely get some SQL questions on the interview process. All right, so 29 people. I think we can start, and the rest will just follow. So, my question to you: have you ever used SQL or worked with databases? Do you have any like clue what it is? Okay, no clue. So most of you never used it, and they have no idea what SQL is or how it can be used, how it looks, how the database might look, right? So if you need like a mental image where to start or to start somewhere, understanding the database and SQL, have you ever worked with Excel spreadsheets or any type and sort of spreadsheets? Okay, good. So I think if you want to imagine what a database is without having any prior knowledge, the very easiest thing to do is imagine a spreadsheet, and I'm going to share my screen. Okay, so just something just like this, where you have different tables within the spreadsheet that store different data. That would be your database, right? You'll have, for example, customers table. Those colors here just for just for the visuals. They don't mean anything. So you'll have customers table that stores data about customers within the database, right? Then you'll have orders table that will store data about the orders within the database. Okay. So yeah, if you think about database, you can imagine something like that. There's some spreadsheet somewhere where it's actually storing data in tables. So one Excel spreadsheet, like a database with multiple tables that store different type of data. This data often can, communicate with one another in terms of you can update multiple tables, you can combine when you're retrieving the data out, and the language, programming language that is adding the data, deleting data, updating the data within those tables is SQL, and it stands for Structured Query Language. SQL is very good at it, and it's very defined. I mean, you have a certain structure. Everything starts when you're building an SQL database with a schema, and schema is like a foundation, a map where everything goes. So the schema would say, hey, within this database, I'm going to have 3 tables. Those tables will have specific columns, and those columns can have only like specific type of information stored. And then you start building on this. You start adding data to the columns. You start populating the table, and your data gets larger and get more and more stuff in it. So the database would consist out of tables, right? In our example, there's customers and then there's orders. Tables will have columns like this. The column defines, the header of the column defines what sort of data can be stored, what type of data can be stored within the column. So like text or a string for like names here, integer for age, height looks like a double or a float. Gender is just one character, so like char. So different type of data is defined within the schema, what can be stored within the column, right, under that column. There's also rows, so row 1, 2, 3, and so on. Those are just, forming the records. There's also a column, special column called primary key, and primary key is a unique ID, which is you don't manually add. Normally, it's auto-generated in increments in value when you add new record. So if I'll add one more record here, I'll fill out all this data for a new person. It will automatically give it new primary key within the ID column. Can you think about a primary key in your real life that you might have assigned to you, especially if you live in the States? Should be very easy, right? Like social security number. Yes. So somewhere in the government, you have a database where social security number might be primary key for your social security services, maybe for your retirement, whatever that, whatever comes with the social security, taxes, whatever goes with it. So your SSN would be the primary key there. It's unique. The new person that gets in that table, virtual table or imaginary table in the government, gets their social security assigned. So, and it's not repeating. You can't have null for your primary key. So there's no person that is registered with social security that doesn't have a social security number. So primary key is the same thing. And then there is something called foreign key. And foreign key is the way how two tables within the database can communicate. And they're building, this relationship is building something called as a referential integrity. So pretty much each table has to have its own primary key. So there's order ID here, and there is ID SSN for our customers here. So both of those tables have the primary key. But when this primary key is added into the orders table, it has the same type of data stored here. It should be matching this column in terms of what kind of data is stored. This primary key that's added to the new table forms this referential integrity, and it becomes a foreign key for this table. So what this means, can you guess if I'll update, let's say, make this all ones, what this foreign key is indicating in the orders table? What do you think that would mean, having those ones over here? Yep. So you guessed right. That means all of those orders, even though they have different IDs, they were made by person one, okay, by Alex. So this foreign key points back to the primary key in the customers table, and we can identify who made this order. Or it can be something like that. So for example, who made order 1346 and bought some apples? Yep, was Bob. So this pretty much it. This is like the very basics, and this is the very foundation of SQL tables, right? An SQL database. So you have all those different things within the table that communicate. So you have a table itself within the database, multiple tables. Tables have columns that define what type of data they have. There are rows that form the records, right? There's primary key. There are foreign keys, right? And the primary keys in each table, a unique primary key, unique value that can't be null. You can't have no value here. And it's auto incrementing when new value is added. There's a foreign key that could be in another table that corresponds with one of the tables, so we can form the relationship there and get like data from multiple tables. And there's a schema, which is like a foundation, a map. You don't see it here, but schema pretty much dictates what kind of tables you have within the database, what tables within the tables, what kind of columns you have. And that's the basics of it, right? That's the base of your SQL based table. There are some NoSQL based database, and they're called NoSQL. We're not gonna look into those today. We're not gonna talk about those, but just for you to know, the NoSQL, if you think about SQL database, is like a spreadsheet, Excel spreadsheet with schema that defines rules strictly. NoSQL databases are more like a Word document where you keep on adding stuff. And the benefits of NoSQL, even though it's not structured as SQL as well, but it's easier to add tons and tons of data in those because there's no many relationship that you can't like violate or break something. NoSQL databases are mostly used for companies that process like terabytes of data daily, huge amount of data, like maybe Google or Twitter or Facebook might be using some of the NoSQL databases. But again, then companies can use different types of databases for different projects. But a very common thing that is being used, especially in startups, like for smaller projects, you eventually when you start working as QA, you will deal with those as SQL based databases. Okay, is everything clear so far? All right. So this will be very hands-on. You will practice a lot. And the goal here for this lesson for you to actually do stuff in practice. I'll give you resource where we will do that, because once you're during the interview, there's quite a possibility they'll ask you some simple SQL transactions. So to retrieve certain data, you'll be able to do that after today's lesson. So yeah, definitely this lesson is not as easy as as you might think that would be, but you'll have to rewatch the video and practice again. in order to remember. But the only way to learn this efficiently is by practicing stuff. All right, so let me share this link right here. So we're going to W3 Schools. Let me know when you have this page open. Here's the link again if you missed it. The link is in chat. Just click on it. It's W3 Schools, SQL, and then try it yourself. You should see this SQL statement window over here where you can actually start typing SQL. Okay, got it? Now go ahead and hit run SQL where you will actually, by this, you will actually execute this SQL statement over here and let me know what you get back. What do you see? Or what do you think you see? All right. Yeah, we got a spreadsheet. So we got a list or table. We got a list of customers. If we would look at our spreadsheet here, we would hit this thing like something like that, right? Similar to this. All of this was all of the data inside. So this table has 91 records, and you can see we don't have the database name for this resource here, but you can see name of the tables that this database has. There's customers, there's categories, employees, order details, orders, products, shippers, suppliers, and so on. The very first thing that you type in is select. And you can see it's all capital and turns blue. This is pretty much SQL keyword that indicates what should be done here. And you're saying, okay, we're selecting something. So this is the command that SQL understands, and we will learn a bunch of those keywords today. So you're saying select, then you need to provide a table name. Then you need to provide what are you selecting. And normally you can just provide the columns. So in our case, I would like to select, let's say, name, age, height, weight, eyes, gender, columns here, and you'll have to list all them, like let's say name, and then ID, and whatever the next column is. Easiest way to retrieve all of the columns that table has is put what is this? A star? How do you call it in English? Asterisk, right? So you're saying select all of the columns with this asterisk, and then you say another keyword to point where from. Again, you can see it turns blue, and yeah, you normally type keywords in all capital. You can type it in lower, and you see it still turned blue. It recognized as a keyword, but as a good practice, I suggest typing them in capital. So this way you can actually, read your code easier. And then you put the table name that you want to get the data from. So go ahead and type any table any table name you want out of this database. You can see the list of the table names on your right over here. So whatever you want, type it out and retrieve the data. I'm gonna go with, let's say, shippers. Only 3 values there. Shippers. And normally, you can also see table names being in brackets like this. So this just to point it's a table name. You don't need to put brackets. It's just for readability sake. Again, up to you if you want to put brackets around the table name or not. And at the very end of the statement, you would normally have a semicolon like this. So a semicolon just indicates, okay, this is the end of my command. Anything that goes after this, or if you'll have multiple semicolons, this will break your SQL, okay? So make sure you have only one semicolon and it's at the very end of your SQL statement. All right, so I'm gonna hit run SQL, and whatever table you choose, hit run again, and now you're gonna get different set of data. All right, so which one did you choose? Which table you chose to run the data, to get the data from? Employees, products, orders. Good. Is anyone having trouble retrieving data from the table? Jeff, in order to work with the tables here and retrieve data, go to this web page. And you will have this window where you type out the commands for SQL statements, and you can execute them by hitting run SQL, and you'll be able to retrieve data from different tables. Okay, so anyone else that could not get their data? So if you're not able to get your SQL working, go ahead and just highlight the whole thing. Press Control C to copy the highlighted text, then go to chat window like this, and then press Control V. It will paste your statement and hit enter. So this way you will copy paste it so we can see what is broken with your SQL statement and we can correct it. Now, if you're on Mac, instead of Control C and Control V, you press Command C to copy and Command V to paste. How will we incorporate this into our QA role? I'll give you a scenario how you might need, why you might need to use SQL. First of all, it's very popular during interview to ask some like basic SQL statements in order to, are you able to retrieve this data or that data, like where John lives or something like that. But as an example for like real QA case, so you have an application that is partially ready. For example, only your front end registration is ready. So you have Facebook, but you can only register new user. You can't actually log in. So you put in some information on the front end saying, you know, John Smith, and you put all his information like his address, phone, whatever, and you press register. So, and your now says registration was successful on the front end, right? But you can't actually log in yet. This feature is not ready. How do you verify that this account was actually created? How do you know that this John Smith is there? Right? So in order to do the verification, you will log in into the application that works with the database. And within this database application, you will run SQL statement. Let's say if you have like thousands, 10,000 of records there, right? How are you gonna find that one? So you just say, hey, select everything from whatever the table name, the database name, and then you provide some other details. We will learn what to provide. And you retrieve the value and see, okay, you see actually that person is there. The data that was populated, added to the, in terms of like phone number, address is correct, whatever you put it on the front end. And this is how you verify that, you know, the front end actually is adding stuff to the database as it's supposed to. SQL stands for Structured Query Language, and it is computer programming language designed specifically to work with SQL-based databases. So it's designed to update the database, add data, delete data, create databases, tables, and also retrieve data, what we're doing right now. Is it the schema that determines the order that these tables are returned in? Schema is determining overall structure. It's like your engineering of the, if you have a house, right, you have an architect first that says, okay, this house has so many floors, there are probably so many front or like a back end or whatever that, or windows, whatever that might be. The whole architecture is like your schema. But what kind of residents you have, how many in each room or apartment, this is all, you know, populated data. So this is not part of the schema. So schema is foundation, like the layout of the project, how everything should be structured. When you're doing select asterisk and then name of the table, you essentially retrieving, and like you can just click on the table name, it will generate SQL statement to retrieve anything. When you're running this and you're saying, give me all of the columns, this is how it looks, this table, how it looks within the database. This is how it's structured by default, like according to the schema, right? So you have customer ID first, all your records are in ascending order based on the customer ID. So the new record that will get added will have ID number 92 and all other data populated here. But if you're not using asterisk here, you can just provide specific columns that you want to see. So let's say I want to just see city, and it's going to be my first column. And then I want to see just the customer name. It's going to be my second column. And then maybe city again, whatever. So over here, you just structure in the response. It cut it off because it's a duplicate. Over here, you're just structuring the response how you want to see it. What is this called? Integration testing or database testing? I mean, this can be called really anything, but you can call it also like a gray box or white box testing of some sort. But most likely when this is done, that would be part of just verifying some functionality in the front end where you input data. Could be part of any type of testing. Could be part of regression testing or any other type. So this specifically is just data verification, let's say. Okay. Does SQL syntax change with different type of databases? There's some minor differences in different types of SQL-based databases. There are plenty of SQL-based databases. This one is probably using like SQLite. There's some like Microsoft. There's some Oracle. There's some different solutions out there for SQL-based database, but it will most likely, the very basic SQL statements will work in all of them, whatever is SQL based. For non-SQL databases, the code there looks completely different. It's not unique. So this will be unique across all of the different type of SQL based. This will be the same, similar across all of the SQL based database. For non-SQL, your calls will look more like some coded API request, or maybe you'll have like database name, I don't know, database customers. Then you'll add a function that you want to do there. Then you'll have to provide some parameters, and most likely it's going to be like some sort of JSON format that you're searching. So I don't know, you're looking for city, Berlin. So no SQL will be different depending on the implementation, could look different. SQL will look the same across all of the SQL databases that you're working in, or the requests that you're doing. And the syntax will be recognized. There's some minor differences, but the very basic generic SQL requests will be understood in all SQL based. So what is difference, for example, in SQL and MySQL? So again, SQL is like your foundation, the very core of it, and then you have like branching out MySQL, SQLite. It's just different implementations of SQL. You know, it's like you have a Mercedes, right? And then you have a blue, you have a green, you have yellow. Three different Mercedes, but they're all like Mercedes. Okay. So let's get back to our customers table. We retrieved again all of the columns, right? One thing with SQL doesn't really care how many like additional spaces you have after your like initial space between your keywords. Doesn't care about new lines. So this is still a valid statement. This will still run. So let's say if I'll change customers to orders here and run it, still it worked perfectly fine. And this provides a huge advantage in terms of structuring your SQL statement. When you have really, really long and SQL statement that retrieves data from maybe multiple tables, it's easier to get confused what's happening. So having it structured properly. Normally I'll have like new keyword on a new line, helps a lot reading it easier. All right, so let's get customers again. We have all of the customers. We got 91 records in that table. Now let's start being more specific. We're going to learn some new keyword here. The search keyword or find keyword is actually where. So this. So you say select all of the columns from customers where, and then you need to provide your criteria that you're doing your search on. You need to put the column name first where you're searching. So let's say where city. And then you need to provide the value that you want this column to have for all the records that you're retrieving. So let's say equals to Berlin. I'm putting Berlin in quotation marks because Berlin data type is text, or it's also can be called a string, or it can be called varchar in SQL. But this is pretty much indicates this is a text value. So you have to have either single quotes or double quotes around it. Just make sure they match on each end. This indicates I'm looking for text. If it was a number, you don't really need the quotations, but when you're doing your search based on the data type that is text, you need to provide quotations, right? So if in our spreadsheet here, we were searching for age, I could do just age 23 because I know the data type there is integer. But if I'm searching for name and I'm searching for Alex, I'll have to put it in quotes. Okay, is that clear? If I don't put quotes here, it will think that this is not text that you're looking for, that this is a column or like a variable. And if you run it, it thinks it's a column. So it will, well, first of all, it's name breaking. So name column doesn't exist. So let's say city, and then I run it. And okay, so it thinks the value here you provided is another column. So it says where city column is equal to Alex column, it just breaks says no Alex here. Okay, so essentially it's not going to run. So let's put back Berlin, try the same thing, run it, says no such column Berlin. So you have to point that you're looking for this text, specific text, right? So let's put it in quotations and run it. Now we found match that actually is has Berlin here. So again, we said was this asterisk that we want all of the columns. We're selecting all of them. We're saying which table we're searching in. It's in customers, and then now we're specifying our criteria of what we're selecting it based upon. So we're saying, give us all of the customers that live in Berlin, essentially, was this SQL statement. And it gives us one person. There's only one customer that lives in Berlin. For example, we can change Berlin for London, and we get like 6 customers, and they're all listed here. So what I want you to do, I want you to get all of the customers from United States. Get all customers from USA. Now, you see how I put the double, what is this? Dashes here, right? So this means that when it turned green like this is a comment. Your SQL will not read this, it will ignore it. This is for other humans. When you write code, you normally leave dashes, thank you. When you write code, you normally leave comments for other people to be able to understand what you did in this code. So this is just a comment. You don't have to type it out. You can completely ignore it. So eat more, I don't know, apples, right? It's good for you. SQL will completely ignore this, but other Q engineer looking at this will be happy that you left this note here because they know what they need to do now. All right. So what I want you to do is get all customers from USA. If you have an error, just highlight your whole statement, do Control-C to copy it, go into chat, and do Control-V. No results. Make sure when you type your stuff, when you type your text here, that it's an exact match. The thing was equal statement here, it's looking for an exact match. So remember how we're searching for Berlin. Let's say I have Berlin, and again, I'm searching, I got one value back, right? One person lives in Berlin. But if I'll put, instead of capital B, I'll put lower b and run it, I'll get no results. Because equal sign over here is literally saying I need an exact match for this search criteria. Okay, so Lydia, you have multiple SQL statements. You can process only one SQL statements at a time here. So you have to delete the semicolon, right? So you can have only one, and it can be at the very end, should be at the very end of your SQL statement. So this semicolon, you delete this. So let's adjust this. So select all of the columns and put on the new line, a new keyword from customers. And let's put on the new line your search where city equals Berlin, and let's run it. Here you go, it works. All right, so were you able to get all the customers from the United States? Is anyone having trouble doing that? Okay, so looks like we all got it. Good. It came up with no results. So make sure when you read your code, because we were basing the search based on the city, make sure that you updated city to a country, because now we're searching for United States, right? So over here, after where, you're pointing to the column name. And if you're searching for country, you should be searching in the column country. Right. The typos, make sure you don't, do typos, because computers, even though essentially, I mean, they're like very smart and they process a lot of information, but they can't understand like typos and other stuff, and they will break. So if I'll do like countries, whatever, I have an extra S here and run it, it just will say, oh, there's no such column, right? Because it's looking for an exact match and output USA was lower instead of capital, just say, hey, there's no results. So takes time, and most of the bugs that developers do in their code are actually introduced by different typos. So. All right, so this is how you search for a single value in one column. Again, it returns, was an example here, city equal Berlin. It returns only records that are matching this search. So if we'll take a look at our spreadsheet here, here's our record, like one row, right? This is our star here. We select all of the columns. So we found Alex, and it's going to return this record. If we had multiple Alexes or multiple Berlins, it would return multiple records. But how do I search for two different values, right? For that, you can use in keyword. Instead of equal, you put in. And then for your search field, you have to use parentheses. So let's say Berlin, and then I'm going to put London. So essentially, any record that has Berlin or any record that has London will be returned now. Now I got 7 instead of 1. Yeah, postal code or address. So you see postal code is combination of text and numbers. So it's still a string value, still text. So I can say postal code. And then let's say this guy. Let's say this guy. So we're searching only for 2 specific postal codes here, right? And let's run it. And we got back those 2 values that we're looking for. No, it has to be either Berlin or. The thing is, we will look at end keyword later. When you use end keywords, that means both of the conditions have to match. So if you put Berlin and London, it will look for a person that's in Berlin and in London at the same time. As an example, it would be Alex and then Bob in the same kind of cell. So this search will never return true. You can't have a person that is in the 2 cities simultaneously. So essentially, Ian is or, where when you run with or, whatever is true is being returned. When you run with and, both of the search criteria have to be true for a single record in order to be retrieving data. Okay, Jeff, if you're lost, just keep on typing and retrieving and repeating, and you should catch up. You definitely will have to rewatch the series and this video. And I mean, the idea here that you're practicing and kind of learning the syntax and what is happening. When you will rewatch the video, you should pause stuff. You should take notes if you didn't understand something. You should do your online research, the most important skill for a QA engineer, and read about things that you didn't understand. Like, hey, what is a select statement? What it actually does? Why is it select, right? So you can learn more. All right, if your stuff doesn't work, copy paste it, we'll take a look at it. So select everything from customers. So you have in and you have equal sign, but in is actually substituting here equal. So you have to remove equal and then run it. So if you have equal, you search only for one value like this, right? And we got 13 record back. That's all USA. If you want to search for multiple things in one column, you use in instead of equal, and then you open parentheses, and then you put values inside parentheses that you're searching for. Now we got 20 back, right? So we got United States or UK. Will SQL be daily in our jobs, or it's more about the interview? It's not going to be daily. It will be an occasional thing. So some QA jobs you'll be doing like front end verification, doing verification of things, and probably, you might not see SQL at all. Others are going to be SQL intensive. There's some jobs in QA that you have to specifically go on tables and verify the data and or retrieve data all the time. So the thing is, there are about, I don't know, there's like trillions of products out there that have code in them, right? All of those products have to be tested. So a person who's testing the web page that where you can buy airplane tickets is going to be doing one thing. The person that will be testing wearable medical device will be doing another thing. Person that will be testing coffee maker will be doing a third thing. So you can't really know what you will be doing until you start actually working. All right. So we learned in keyword. Go ahead and get a person for 2 different cities of your liking. So whatever you want. So get customers from 2 different cities. Go ahead, type it out and see if it works for you. So black box testing is when you have no clue what's going on inside, right? It's like a black box. This term is actually coming from programming. You put something in the box, you feed in money, right? And what do you get back? Like, let's say some lottery ticket. When you got the money in, you got the lottery ticket back, you don't know what happened inside the box. You just verifying the data that's being returned from that black box when you got some input there. So you have no idea. Gray box is kind of, some of what things that are happening, like you partially know what's happening in that box. And white box is pretty much like you see through it, you know the code, you go into the code and you can understand everything, like what is the functionality, how it's all structured and why it's happening. So black box, you don't see, you have no clue. Gray box, you partially know what's happening inside the box. White box, like see through. You know all of the process that led from point A to point B. All right, so get 2 customers from 2 different cities. And anyone having trouble with retrieving their data with their SQL statement? If you do, just copy paste it. We'll take a look. Yeah, if you're having like issues with database, you can click restore database here, and it will bring it back to like original state if someone messed it up. All right, so nobody posted their code that it's not working for them, so I assume we're all good. All right, now we're gonna learn or keyword. So where country, let's say, equals USA, I say USA, or country equals Germany. So this will give us all of the records, customers that live in states or they live in Germany. Okay. You can use or. So or will return anything that is any condition that is true. So for example, if I'll do this, can you guess what I'll get back? So it looks through the record and says, okay, is any of country has banana land? If so, it will be true condition. If no, it will be false. Is any of the country has Germany? If so, it will be true condition. If no, it will be false. And it will return back anything that is true for or statement. Right, you'll get only Germany back because, okay, this is true. We have this, I'm gonna show this. If you will use and there's another keyword, it will return records only when both are true. Is there any person that lives in Banana Land and Germany? So what do you think this will return? Using the end statement here. I will just say no result. Because this is false, this is true, but in order to retrieve any information, it has to be true for both for one record. So normally you use and to narrow down your search. So for example, if I'll have city, Berlin, and country Germany, maybe we have a customer that lives in Berlin, but it's actually a city in the United States. So I don't want to search only by Berlin. I want specifically Berlin from Germany. With and you narrow down the search. This is true. This is true. Let's see. I'll run this. All right. So we got one record back. This person or this company, whatever, who is the customer, doesn't matter. Are they from Berlin? That is true. It's right here. Are they from Germany? That is true. That's right here. Okay, we got match for both. And we got one record back. All right. Is that clear? All right. So one person asked me here, they did something. Let's take a look. So selected all of the columns from the customers table where country. Remember, in when you search for multiple statements for multiple values in one column. Or so you're still search for USA and UK. So you got all okay, no, you actually get only UK here. The search only ended on in. He never got back. So if you want to search two of the, you have to restructure your statement. So if you want to search with using in, both of the parameters have to be within the parentheses, right? Just like that. So you're saying select all of the customers from United States or from UK, and you run it, and you got your UK USA. After in, you have the parentheses open, you put values that you're searching for. If you have equal, then you'll have to do this, provide one column, then you put or, provide the column that you're searching in again. And I don't like, I prefer to type out the same way that it's typed in database, like for column names. So it's not all capital countries, just C, or country equals UK. Or you can do this, right? Then you'll get back your 20 results as well. The difference between in and or, in is searching within one column. With or, you can do multiple things. So you can say, let's do, I want to see person was this postal code or city equal to Berlin. All right. And then when I run this, I got two records back. I got person was this code, was this postal code, and I got person that lives in Berlin. So two different columns were searched in using or statement. Other questions we could practice. So by the end of the lesson, I'll provide some information. I'll provide this text document for you. You can watch the video, practice with this video, and then was the recording, and then you can follow along the document. The document itself actually has more information in terms of how you can install your own database management system on your machine, how you can create your own database, how you can add data there, all the fun stuff. Can you send the link again? Okay, the link is right here. All right. Can you explain and or difference? So when you do an and, you're narrowing down your search. With and, one record, single record, was and, have both of your search criteria to be true in order to return something. So is there a person that lives in the postal code WA11DP in the Berlin city? Is there a person like that? There's no such person. Got nothing. So and looking for both of the conditions in order to retrieve something in a single record, in one record. So in this record, when you use an and, both of the conditions or whatever, how many ever conditions you're searching for have to be true in order to return that record. When you're doing or, it actually searches for any match for this condition in any record. So, okay, I found Alex here, and then I found Nick here. I could do like where name equals to Alex or name equals to Nick, and it will give me this record, and it will give me this record. So now where I'm doing or, and I'm running this, I got two records back. I have one person living in Berlin, and I have one person living, or one customer living in this postal code. All right. How are you doing so far? Are you guys enjoying SQL? All right, awesome. So let's take a 10-minute break, and then we will be back after the break. Okay, so we're back. Can you hear me? Awesome. All right, so we learned select key, we learned from key, we learned in, we learned and, we learned or. You can actually also say what do you not want to see, so you can use not. For example, select everything from customers where country, and then say not equal or not in. Let's do multiple values. So Germany, USA, UK. So you're gonna get everything else except those three. Let's run it. We got 60 records back instead of 91. Okay. Or you can say when you actually use a not equals, you want to do before the column. So we're not country equal Germany. They got 80 records back. There's a possibility if you don't want to see something, you want to get everything else, you can do that using not keyword. One more. All right. So this is great. We can search now on the exact match. What about if we want to look for something where we don't know the exact match? So for that, we can use like keyword instead of equal, like. And for example, remember for city, we're doing Berlin with an equal sign when there's an exact match and we had lower B, it wouldn't return anything. But with the like keyword, if we run it, still got the value back, right? That's pretty cool. With like key, you can also do searches a last name only if it's last name. We're searching in the city column, right? And we don't have last name here, but yeah, there's no last name column. So, but if we were looking here, so employees, last name, select everything from employees, say where, then last name, instead of equal, we put like, and then we say Fuller with lower F. Let's run it. We got the value back. Or if you even did like this, it's capital R at the end, like an accident typo, still got the value back. If we get equal and run it, no result. Let's take a look at this statement. So reread your code, but I'll give you a reminder. You'll probably find the error yourself. You can have only one semicolon at the very end of your SQL statement. For the whole statement, there has to be only one semicolon at the very end. All right. Now, it's quite common with the like keyword to use wild characters to make your search even better. And there are two wild characters that we're going to learn. One is %, and % equals anything. Like it can be like whatever, like really whatever. And there's underscore. Only. Okay, so one underscore stands for one character that can be anything. So let's take a look at our search. So let's do select everything from customers where country, like, and I'm going to give you an example. It doesn't matter. Max C. Okay. So what do you think that's going to return? Right. Okay. How about one underscore? Error. No, let's run it. So we got Mexico back. So underscore stands for one character that can be anything. It is used with the like keyword. It's a wild character that you use it for search. Like you don't know some details, right? Or you want to have multiple values that have some matching in their data. So like ignores the actual capitalization. So it doesn't matter if it's all lower or all capital, or it's actually like this. And a one underscore over here means it can be any character here. And we have a match with character or O, it's character O. So hold on. Interesting. Okay, so Mexico, right? So here's our one character that can be anything. We're matching with O, and we get the value back for everyone who is in Mexico. Is that clear? All right. So for example, if I'm saying any country like underscore, 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 any ideas what I'll get back? So one underscore for one character that can be anything. Right. Do we have any country that has 3 letters? So run the search and we got the USA back. How about if I'll do this? What I'll get back? All right. What I'll get back was this. All right. What about one underscore? Actually, the U and underscore. Just one. What I'll get back? All right. So 2 characters in this search. First has to be U. The second can be anything. Right. Run it. UK. All right, so retrieve any city you like, and you can use one underscore or multiple underscores, run it, and then paste it in the search. So get any customer from a city of your choice. Use at least one underscore. So underscore S underscore. So if you grab this value, first character can be, so if you grab this value, right? First character can be anything. That's an underscore, right? So, okay. For anything I put here, U. Second value is already predetermined and specified is an S. And the third value here can be anything. And let's say you put A because we have a match. And that's how you get USA. Yes, you can use more than one underscore in your search. So essentially you can search USA with 3 underscores, with US underscore, was U underscore underscore was underscore underscore A. And if you have two underscores, now this is no longer matching because you have one underscore, second underscore, okay, and now you have A here. There's no more match. So this will not find USA. If you have two underscores, it will find U, for example, and then it would find K. Two letters here, two underscores, it's gonna match UK. Yeah, you can use one underscore, you can use multiple, whatever you want. All right. So you have a statement that you ran and you didn't get anything back. You want me to help with your statement with the underscore search? Post in the chat. Let's take a look at it. So if we use three underscore, does it mean any name with three letters? Yes, that's exactly what it will mean. All right. So here's one of the examples. Select everything from customers, where, city, like. Okay, so this will work. Yeah, good. Okay, so looks like we're all good so far with the underscores in the search, right? So you need to use like, and then you can start using wild characters. If you'll have if you'll enter equal sign here, we'll be looking for exact match. Not gonna find anything because it will be literally taking underscore for search value. So you have to use like keyword. Yeah, how to search for Mexico, right? Was this E? So you can probably just have E substituted with underscore. And here you are. So let's say city, right? City like Mexico. No result. Because, okay, so in order to search for the city, for the full name, right, with underscore, you'll have to provide the full city name. Country like, so let's see. And it's Mexico DF, right? So if you're searching where city like Mexico was underscore, you have to provide full string, full text. And then when you search it, we'll find it. You got 5 values back. Now, with this search, we're actually going into our percent sign. So percent sign can stand anything. So if you don't want to type full text when you're searching for Mexico DF, you can go ahead and put Mexico like this, and then you put percent sign and run your search. And then see what happens. So percent signs can be anything, however long. So for example, if I'll do select all of the customers where country like M percent sign, what will I find? Any guesses? What will I find here? Any country that starts with M. Any country. Because over here, percent sign can stand for anything, however long. Anything that starts. M has to be the first character though. It's this search is specific, right? What if I'll do percent sign O? What will happen? Any country that ends with O, right? Because you have O at the end. Percent sign and then O. Still got Mexico. Mexico is like, let's do instead of O, let's do A. All right, and now we have 25. Canada, Argentina, Austria, USA. Okay, if you want any country that has M, you can put percent sign, M percent sign and run it. Now we have Germany. Let's just grab it to show you. We got Germany here, right? So up to an M can be anything. So here's your percent sign. And after an M can be anything. Here's your percent sign. With Mexico, apparently nothing is also percent sign. So nothing is also there. And then you got your M right here. And then percent sign over here can be anything. Anything including nothing, right? Is that clear? No. Okay. What is not clear? Eddie, what is not clear? No, because the thing is here, percent sign can be anything or nothing. So this having M here, Mexico having M, here's your nothing, then your M, and there's your anything, right? Does that make sense? That's why it found Mexico. If you want something just to begin with M, then you'll remove the percent sign here. If you want something just to end with M, you put it here. Having 2% sign, then it's yeah, you have it at the end. So this is very specific. Also, interesting enough, when you put space in your search between percent sign, it will search for those spaces as well. So nothing found in cities, but let's do customer name. So this search says anything that has at least one space in their name. And then I got two names, a name was 2 words here and 2 plus here. So if I'll do something like that, I'm searching for a customer name that has at least 5 spaces. 1, 2, 3, 4, 5. Run it. And there's one person right here. You see this E, it's number 3, right? 1, 2, 3. Let me substitute with 1 underscore. See what happened? Still find it because E is just one character. We put it right here. This is your E. Still found it. If I'll put here G, there's nothing. I put E, here's value. I put V, nothing. I'll put underscore. Here's your guy. It's probably like a store name. I don't know what is this. Can't read. Okay. Does it make sense? How do you search from the first letter? So you put a letter first, and then you put %. And here you go. You start searching from the first letter. Anything that starts with M. M, M, M. We got 4 customers starting with M. All right, guys, go ahead and write a statement that uses both % and underscore in your search. So get customer using all right. Here's an example. So select everything, all of the columns from customers, where country like, one character, A, anything. Let's see. Got 41. So apparently there are a lot of countries where the third letter is A. France, Brazil, Spain, Italy, like a lot. All right, good. Is anyone having trouble doing this? Okay, looks like everyone's good. I don't see any code that is not working in the chat. All right, so now we almost, I mean, we can search for anything pretty much with all those keywords. We can search now anything really. In SQL, you can also use functions, which are doing something based on your search. So for example, let's take a look into our products, right? So we selected everything from products, and products have price, right? Different price for every product. I'm like, okay, I need to know my average price for all of the products. How can I do this? Now you can do functions based on your search results. And you can do, for example, select, and then we're going to say select price column only, right? Okay, here we are. We got all of the prices here. All right, how do I find average? You provide a function name. So in our case, it's AVG, average. Then you open parentheses and you put what are you executing function upon. So we're doing it on with the price and run it. Here's our average price, $28 and a lot of numbers after. So you can do average price, then you can give it alias using AS keyword as all, and you have to put it in quotes if you're using multiple words. So all products average price. And when we run it, you see this got renamed because we used alias for this column. It's the alias displayed, and here's our average price. Okay, so you can use different functions. how can that be useful? I mean, this is obviously one of the cases, but let me show you this. We're working with our customers, and now we want to know top countries where we have the most customers. How can we do this, right? So what we can do, let's first select the columns we're working with. So we want to know, let's first select country. All right, so here's our country column. It just lists all 91 records one by one based on its primary key from 1 to 91. So all of the countries listed, 91 records still, right? So first column will have a country. Second, we will have a function count. And now we're still counting countries. All right. Now, if I'll run this, it's going to break the statement because we have our first country, Germany, which is under customer ID 1, right? It's Germany. And then we also counted all of the records, which is 91, which doesn't make much sense here. So it ends up on this column because it's not displaying everything. It just ends up on this count function. All right. Not so useful, not so far, right? But what you can do another function, well, not function, but a keyword. It's called group by. And then you can specify what column you're grouping by. And I'm going to group by country column, meaning like all of the matching values going to get grouped together. And if I run this, all of a sudden we got list of the countries that we have and how many customers we got in each, right? The next thing you can do, you can order, you can do specific order. Everything by default is ordered by primary key. We don't have primary key in this generate table anymore. Now, by default, it's ordered by first column from lowest to highest or from A to Z. And you can see Argentina, Australia, Belgium, and so on. You can specify your order. So you'll say order by, and now instead of ordering by default first column, you're saying count country. So you're ordering by this column right here. Now you go from the highest, from the lowest to highest in the count country column, which is not what I want. I want like top 3. By default, there is a keyword that says ascending. So from lowest to highest. You can change that and add descending keyword. Now we're going from highest to lowest. And you can limit the response you're getting back. So you want top 3, limit to 3. Bam. The last thing that I would improve in this column, instead of count country, I would give it alias. So let me put it on the new line here as total customers in country. So it's not confusing, like, what is this, right? So I'm giving it alias and run it. And here we are. We just did some search where we defined top 3 countries with the most customers. Now I want you to do the same thing with cities. Okay. Find top 3 cities with most customers. When you're done, just copy paste your statement. Yeah. So you want to find. I want you to find top 3 cities with the most customers. We just found top 3 countries with the most customers. Now I want you to find top 3 cities with the most customers. So this statement here is looking for top 3 countries with the most customers. I want you to find top 3 cities with the most customers. Okay. Jeff, you got it. But you were starting like I don't understand what's going on, and like right now you just did the statement first, which is the most complex so far. It's funny. uh, but okay, so do you understand what we just did here, right? So we selected column city, and it's displayed right here. And then we counted all of the cities over here in the second column, gave it a name. This is just pointing to the table. Then we said, okay, we want these values to be grouped, and this is where the grouping happens. And then we ordered them from highest to lowest, and then we limited the result to 3 that's coming back. All right. So, like a real interview question would be, and something that would be asked, hey, you have customers, you just added a customer, you just added a customer on the front end, or someone just added a customer on the front end. Can you get the last customer added to the table? So you can do that. So you will do select select everything from customers, right? I'll help you order by. What do we need to order by in order to get the last customer added? You guys guess? There's no date here in this table. What's the primary key that gets auto-populated? Right. So we're ordering by customer ID, but everything by default is ordered in ascending order from lowest to highest. What do we need to add? Which keyword will help us here? So we'll add descending. And now we need to have only one value, right? So back limit 1 and run it. Now we know the last value that's been ordered added to this table. You don't need to know who it was, his name, the address, nothing. Just you know that there's primary key auto-populated and you want the last value added. Here it is. All right, so this is all nice. We practiced a lot. Let's talk about joining stuff together. All right. We're not gonna use this, and I'll be showing you more. So remember about this referential integrity. There's a primary key here that's added to another table, and it becomes a foreign key in the other table. This is how the join statement actually works. At your work, you'll have some sort of an application, database management system that will help you work in a database. So for example, over here, I'm using this DB Lite, DB browser for SQLite, and you'll have it in the text. I'll send you the text at the end of the lesson, the link to this document. And over here, you can see there are tables, 3 tables, classrooms, enrollment data, students. Within those tables, you got columns, data type is defined. This is your schema, pretty much. You can browse by the table and see like what's inside. And it's kind of easy when you have a visual like this, but it gets hard like if you have thousands of records, right? You still have to do your SQL statement. So let's do select, and you've seen this. Select everything from, what do we have here? Let's say students, right? Students table. See how it turned green? It says it's a table here. What? Students? Select every. What happened? Hold on. from students. Okay, I don't know, some weird bug. No, let's see if it recognizes the square brackets here. Yeah, it recognizes square brackets here, but it also highlights the green color for you to know that's table name. All right, so and we got all of the students. So how are we joining tables together? Let's take a look at the visual representation of the schema for this particular database. And here it is. So we got students table. Student table has 5 columns. So student ID, first name, last name, country, date of birth, primary key, student ID. There's enrollment data table that has 4 columns: enrollment ID, which is primary key, student ID, which is a foreign key for students table, classroom ID and grade columns. There's classrooms table that has classroom ID as a primary key, class name column, and then students enrolled. Classroom ID, you can see it's linked to enrollment data, whereas classroom ID is a foreign key. All right. So probably the join statements that you will be using are just the regular inner join, or it's called like just regular join. This is document I'll be sharing with you, but there are different types of join statements. There's inner join, and inner join returns matched record both on the left and the right table. This is pretty much everything you need to know about the join, because this is the mostly used join. Other joins like left join will only return everything from the left table and only matching records from the right. Right join will do the reverse, return matching records from left table and all of the records from the right. Full outer join will return all of the records from table 1 and table 2, meaning like over here, if there's no matches, like something is mismatching in those records, it's just gonna return everything and say null for the values that are missing or not matching in each side. You'll have like a bunch of nulls if some values are not linked. But we will be using regular join, and let's get to that. So first we're gonna do 2 tables. All right. So how do we join stuff? Now we have this nice table return. It's pretty small. It's easy to read. If you want to add another table that you want to see, you add a join statement, and then you have to provide a table name that you will be joining together. So what can we join according to our diagram here, or like visual schema? What's the table name? If we have our students here, what's the table name we can link together according to the diagram? Yeah, the table is enrollment data table, because that's where the foreign key is, right? So enrollment data, and you see it turned green. So now it defines, okay, this is also table. All right, awesome. Now you have to provide what are you joining it on. So you say on, and that's kind of easy. So students dot student ID. So you're saying that table students has student ID column, which is actually equal to enrollment data dot what? Guess what column it's equal to? Student ID, right? Yeah. So we got the statement, we run it. And all of a sudden we got like a huge table. And you can see their values that are repeating. But the reason why it's repeating because Alex is enrolled in 5 different classes. And you see there's enrollment ID and classroom ID that repeats and has 5 grades different for those classes. Like, okay, I don't want that complex table with asterisk here. So how do I define if I'm using multiple tables, columns that I want to see? So you need to provide a table name. So from students, I want to get last name, right? And then from enrollment data, I want to get only the grade, for example, right? So, and let's run this. All right, that's nice, but something's missing. I want to also grab our classrooms here because I want to know the grades, what the grades for, what classroom. And then you're doing then another join and help me with the table name. What is the table I'm joining here? Right, it's classrooms right here. It's in the diagram, you can see it. So I'm joining classrooms and I have to provide what I'm joining on. So I'm saying classrooms, classrooms. Let's start from the enrollment data. So enrollment data dot, what's the foreign key for the classrooms table in enrollment data table? Classroom ID, right? So class enrollment data classroom ID is actually equal to what? Classrooms, classroom ID, right? Here we go. Okay, that's awesome. I'm still not getting the second column. I want to know the actual class name. So over here, I will provide this my first column. This is the second. So I'm going to paste the new column between them. This is going to be the second one now, right? So I'll put classrooms dot class name. And let me run this. And here we go. Now I know Alex enrolled in those 5 classes. That's the grades. So we just joined 3 tables together. Now, what you might see, remember we were doing like alias, right? Not sure. Yeah, we were doing alias like this, doing AS, but you can actually skip AS and you can do just space and the character. So every time first time you're retrieving table, you can give it alias. So for students, I'm gonna give alias as S. For enrollment data, I'm gonna give alias as E. For classrooms, I'm gonna give it alias as C. Everywhere else, I just substitute the actual table name with alias. So C, E, 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 C. And this is like your statement. You run it, you get the same thing. For example, I want to get student ID, or maybe not student. Let's do. Let's do first name. So you want to do first name as the last column. It's S dot first name. So we're saying student's first name is going to be the last column we're providing here. Let's run it. And here it is, got added. Alias is defined right here. Alias is defined after the first time you retrieve the table name. So students is defined, the alias is right here. After the space, the character after the space. So we skipped this AS, still recognized it. So S, all right. And that's pretty much it. That's all you got to know. That's like, this is more than basics. This is definitely, right now we just covered in 2 hours, we covered like 3 months worth of college here for SQL class, for your database class. I'm gonna give you a text document that you can follow through, and that document is actually has like more details. You will be able to install the SQLite on your machine. You will be able to create database and populate it with data. If you just follow along this document. But I recommend just rewatching the video, repeating everything that we just did. If you want to set up your own database using document, that's great, do it. This way you will be able to do the same thing within your own database on your machine. All right. How do you guys feel? You just worked through your first programming language, if it's your first, of course. And you learned a lot. Yeah, I mean, if you're feeling like, okay, what just happened? Like I'm freaking out. This stuff is too complicated. It's not for me, or whatever you might have, in, whatever thoughts that you might be having that are not like the best experience. Just understand it's almost everyone has those. It's fine. It's complex. This stuff is, I mean, it's programming. You're programming, and you just covered college, 3 months of college in 2 hours. It's a lot, but you definitely hands-on, you're practicing it. And if you repeat it, if you watch the video, redo things, and then follow the document, you'll be perfectly set with SQL for a QA engineer for the rest of your life. Because this is the basic that you're going to need as a QA engineer if you will be working with SQL. This is more than enough. Is the doc Mac friendly? I think you can get SQL browser for Mac as well. There's I mean, the installation for the SQL browser, for this tool, DB browser, is on the webpage, and I think it supports Mac. Should be. Can you give us the link? Yeah, the link is in the document I provided, but I can give you a separate link for this tool if you want. It's right here. Let's see if it supports Mac. Let's see. Yeah, it's right here. Yeah. So it should work for Mac as well. All right. I think that's it for tonight. We're done. Guys, I wish you all the best. I wish you, remember, I mean, it's going to take time, right? Learning this stuff. But think about this. You can spend 5 years on a job that pays you whatever, 15, 20, maybe more dollar a month, but still you'll be doing it for 5 years, right? Or you can spend half a year, even max half a year with bootcamp and all the search and get the job that's going to pay you up to 100 and even more, 100 something plus as you progress, 100K a year. So it's not that much of investment to spend some time, because those 5 years still going to pass. And if you're still doing, 8 to 5 at Subway for, I don't know, 10 an hour. But instead of that, you can do this and just dedicate half a year and really learn the skills and get the QA job and get 100K. What will you choose, right? It's easy choice. All right, guys. Thanks so much and all the best. See ya.